For number 18, the hardest thing might be the fact that derivative of tangent is secant squared, and that's the part you might have forgotten. So let's go over number 18. Can you guys see this from the back? You can see it? Okay. So keep in mind for e, it's basically e to that same value, right? So I'm going to write on here e to the tangent of squared x, and I'm going to circle this guy. We have to now derive this guy. To derive this, I'm going to rewrite this to that, so we have squared on the outside. And when I have squared on the outside, do we see chain rule? So we have, from here we're looking at, chain rule says 2 comes out, then I have tangent of x. You could write understood 1 if you want to. And then you derive the inside. What is the derivative of tangent x? Secant squared x. In that option, I'm going to put a little line here. It's given to us by which one? D? Do we all agree on that? Yep. And notice it ordered it in the descending order of the power, which is perfectly normal. Not descending, ascending. So when you're multiplying, it doesn't matter what comes first. All right, number 20 was the next one. Is that correct? Okay, number 20. Okay, 20 was the last derivative rule that we went over last week. Do y'all need me to put up the card? Or are you guys okay without it? You're good, okay? If you have the card, use it. Hopefully you have it memorized. So on this one, we're looking at arctangent. So our arctangent rule was 1 all over 1 plus this guy squared. So let's put that in parentheses. And then it was a derivative of the guy in the inside. So again, I'm going to circle just to reemphasize. So derivative of e to the power of 2x is simply e to the 2x, and then you derive the exponent. What is the derivative of that exponent? 2. And just by looking at this, I know we can eliminate a and d. That looks like the derivative of arcsine. So which is the best answer looking at what we have so far? B it is. Okay? So if you want to get in a habit of circling your the u value according to the formula, that will be very smart. Are we okay with that one? Okay? Okay, let's move on. What was the next number I said I was going to go over first? 21? Is that okay? Whoa, my stapler almost fell. Do you guys want a trick to this, or should I go over this traditionally? What do you guys want? Both. Both? Okay, I'll do both and the trick then, or as in both. So the rule for the natural log was 1 over the u, right? So I'm going to circle this guy. So for the derivative, it is 1 over e to the 2x. And we derive that guy right here. When I do, I keep that as it is and derive the exponent. What's the exponent derivative? 2. Now, technically, if I have anything without a fraction, it is over 1, right? So what do I know about all of these? They cancel. So we know our final answer is 2. So looking at this, it's got to be B. Now, I'm going to use a pre-cal trick. Listen carefully. This trick, you're going to go, what? I wish I would have remembered. So write the following, guys. If you remember back in pre-cal, I'm going to write out f of x just to make it proper. Natural log of e to the 2x. And I know I did not put the parentheses, which I really don't need. What is the understood base of natural log? E. And I taught you guys a little trick. When the little one and the big one with the L natural log, what happens to them? So if this function is 2 to the x, what is the derivative of this function? 2, and guess what? They're identical. So if you see those tricks from pre-cal, use it, okay? It doesn't matter. Although if you have the rule, it's always going to work out. Good? So I said I was going to do one more problem first. Which one was it? Was it 22 or 24? 22? Okay. And the latter problem is pretty popular on the AP test. It's a good question. All right, let's see. Sullivan, let's read number 22.
Yeah, okay, give him a second.
Hey, give him a break.
A ladder 10 feet long rests against the vertical wall. If the bottom of the ladder slides away from the wall at a speed of 2 feet per second, how fast is the top of the ladder descending and the top of the ladder is 8 feet high?
So let's start by drawing our right triangle. And I like to call this the longest IC. And because A sounds like the altitude, I want to make that the height. And B as in the base, the bottom. You can always switch the A and the B. It does not matter. If the ladder is 10 feet, that's going to go on the where? On the C. What other information do I have? The ladder is 8 feet high, so that's going to go for what letter? 8. And just by looking at this, we know the base has to be how many? 6. And let's go ahead and write out everything we need. It says to find something. So how fast is the top of the ladder ascending? So if we're looking at this, not ascending, descending. Did y'all hear what I said? Descending. And descending part is going down. That's an A part. So we're looking at dA over dt. Let's do an anticipation. If the top of the ladder is coming down, should that be positive or negative? Negative. That's going to be a good self-check. Go ahead and put negative on there. Because I know when you guys mess up, typically, it's not putting in the negative because you're rushing through. Okay? But what's sad is you got 99% of the work done. But because of that one sign, we're screwed. So from there, the when is basically, I'm going to write out all of this or draw the arrow. It says when the top of the ladder is 8 feet high. So that was given to us. So are we okay if I just draw the arrow to the picture? Okay? And then the given rate. The given rate, it says the ladder is sliding away from the wall at the speed of 2 feet per second. So we're looking at dB, because from the wall is the bottom, dt. And that's going to be 2 feet per second. Okay? And if the ladder is moving away, would you agree it's going to be longer and longer than 6 feet? So I'm going to leave it as positive. And the equation on this one happens to be our Pythagorean. A squared plus B squared is C squared. So let's write that out on the top so we can derive it. We have A squared plus B squared is equal to C squared. And we always derive it with respect to time for all the word problems. So derive this whole function with respect to t. So what is the derivative of a squared? 2a. And we have to add something. dA over what? dt. Plus, what is the derivative of b squared? 2b. By the way, that's a b. And it's dB over dt. And the last one, what is the derivative of c squared? 2c, and it's dc over dt. Okay, let's see what I don't need. If the ladder is falling and falling and falling, does the ladder grow or shrink at all? Nope. So what is going to happen to all of this guy right here? There's no rate of change. That's gone. So let's plug in what I know. We know 2. My A is 8. dA over dt is what we are looking for. And then it says 2 times a B, 6. And we know dB over dt is 2. Oh, did y'all see that equal to? It's a plus. 2 is equal to 0. And let's see if we can solve for this. And I'm just going to do it on the calculator. Let's assume I know no math. I know I have to subtract that guy out. So alpha y equals negative 2 times the 6 times 2. And I need to divide it by the coefficient of dA over dt. 2 times 8. And again, we're anticipating a negative solution. So we got negative 3 over 2. So we know dA over dt is negative 3 over 2 feet per second. And yes, it is descending, but I'm not going to write the descending part because the negative already is implied. Rosie, question?
So how do you figure out you're finding A?
Because it says, how fast is the top of the ladder descending? How fast is it going down?
horizontal part, so that's just, right? Just roughly.
Yeah. On mine, I made the horizontal part B, and I made the A as a altitude as in the height.
You just plug in, what you plug in 2 for,
2 in place of dB over dt. Because that was a rate that was given to us.
okay, got you.
Mm-hmm. Priscilla?
How'd you get 6?
6. 6 was found by Pythagorean theorem.
Oh.
Okay? All right. How's our time? Do we have time for 15 and 24? Do y'all want the 24? Yeah? Okay. And look how nice the formula's given to you, huh? Just keep them on the AP test. You should have that memorized. All right, number 24. Let's see. Stefan, read that out loud clearly, please.
The radius of a sphere is increasing at a rate of 3 inches per hour. At what rate is the surface area increasing when the volume of the sphere is 36.5 cubic inches?
Okay, let's write out Fuigi. I know some of you guys probably don't need this, but I'm just going to stick with the rule. It says, what rate is the surface area? So I'm going to write ds as in surface area over dt, because we're looking for what is the rate of the surface area, and I'm sticking with the s for the surface. And the when part, it says when, what do I know about the sphere? The volume of the sphere. The volume is 36 pi inches cubed. And it says the radius is a given rate. So we know dr, as in radius, over dt. It is increasing. So we're going to leave it as a positive, 3 inches per hour. And then the equation given to us is pretty much right there. So I have a question for you guys. Since we're looking for the surface area, are we going to derive the volume or the surface area? Clearly the surface area. And we'll see how the other value might help. So we know our volume is given. We know, could we find the radius by the surface area, by the volume? Okay, so let's take this guy first. We have 36 pi is equal to 4/3 pi r cubed. What can I cancel out on the left and the right immediately? And because it's a calculator portion, I'm going to do one go. So watch what I do so you're not making silly mistakes. Any calculator portion, you should avoid doing more work. All ready? So I know I have to divide it by 4/3. So I'm going to do alpha y equals 36 on the numerator. The denominator has another one, 4/3. Oh, that's not it, 4/3. Third. And then it says we have a cubed. What is the opposite of cubing? Cube rooting. So I'm going to go all the way to the beginning. And I believe when you go to math, there's a cube root button, which is option number 4. Oh, look what I have to do. I have to copy all that again. Oh, well, I'll do it again. And I'll delete the one right after. So I'm going to delete what I don't need from the bottom. There you go. And that should give you some clean value of 3. So are we okay with how to find the radius there? Again, avoid doing too much work. You have your calculator on you. So let's go ahead and derive. So we're deriving the surface area. So we have, I'm going to write surface area as in just the s, since that's what I have on the rate. Is equal to 4 pi r squared. So we are deriving this function with respect to t. So what is the derivative of s? 1, 1. So I'm not going to write the 1 since it's understood. I'm just going to write out ds over dt is equal to. So here's what's nice. Check this out. We're looking for ds over dt, and that's already by itself. And that's always good. Okay? What is the derivative of 4 pi r squared? 8 pi r, and we need dr over dt. So all I need to do at this point is simply plug in the 3 into the NPs. So we have 8 pi. We know the radius we found was 3. And coincidentally, the rate is also 3. So we know we're looking at 3 times 3 is 9. 9 times, is that 9? How many is that? 72? And then we're looking at pi inches squared per hour because it's surface area squared. Okay, Sam, you wanted 15 still, correct? Yeah? Okay, let's do 15. So 15 came from last week, so let's see if it's a good reminder. Maybe it is. Are you guys okay with this page? I can move it. Okay, number 15. I know, I'm going to fix it. Thank you. Very helpful, Priscilla. All right, number 15. So let's see what I'm looking for. If I am looking for g prime of 4, if y'all remember the derivative inverse, the definition basically said that is equal to, no, I think I have enough room, 1 over f prime of g of 4. Again, this came from your card that we made. If you're not studying the few cards we make, that's going to be pretty sad. So we have to look for what is g of 4. Is there a g of 4 anywhere? If these are inverse functions, I could take f2 of 4 and simply write out g4 of 2, always. So that's going to give us 2. So I'm going to write out on here 1 all over f prime of 2. So now we're looking for f prime of 2. Is that given to us? Which is 5. So this is equivalent to 1 over 5.